Okay, so now it's my great pleasure to introduce Margaret McCullough, who will be talking with us about her research in Denmark at Aarhus University, where she's finishing up her dissertation, almost done. And Margaret and I know each other from the University of Maine, where she did her master's, and where she also owned and operated a small organic vegetable farm. So Margaret has a lot of great experience to share with us, and I'm excited to hear her presentation. So take it away, Margaret.
Awesome. Well, thank you again, Brian, for inviting me. It's a pleasure to see you again as a friend, but also to be given the opportunity to share my work with the audience here today. So thanks everyone for coming. As Brian mentioned, I left the Northeast and have actually been living in Denmark for the last 3 years, where I attended the University of Aarhus, which is the second largest city in Denmark. It's located in the northwest of the country, and actually lived and did the research that I'll talk about today in a very small town called Flakkebjerg, which is in the west, about an hour away from Copenhagen. And you can see they've got some beautiful facilities with lots of greenhouses and agricultural land surrounding that I got to stay at and work with the folks within the agroecology department there. Including, I've got to give a big shout out to my direct supervisor, Bo Melander, who's a well-known non-chemical weed management researcher. So today, I'm going to talk about 4 different research projects, all of which are going to be included and comprise part of my dissertation. So they all have a through line relating to how we might better control weeds that are specifically growing within the crop row, and how we might do that when using non-chemical weed management strategies. So when herbicide is taken out of the picture, we think of some creative ways, I must say, in order to address weeds growing in the in-row zone. With regards to that, I do look at quite a wide variety of strategies, which is appropriate given the variety of tools that we have on hand for non-chemical weed management. So as I go through, we might be taking some rather abrupt turns, but I've got some really nice conclusive takeaway messages to leave you with at the end of each experiment that I'll discuss today that summarize and consolidate information quite well. So stick with me. It'll be a fun ride. So when we think about weed management from a non-chemical perspective, to me, there are 2 very distinct zones within the field. We've got the space between crop rows where there is no crop and only weeds. And in this area, we actually are quite good at controlling weeds here by using aggressive cultivation tools such as hoes. And we can control weeds in the inter-row zone well throughout crop growth. So the inter-row zone, it's a fun place to use cultivation tools, but it's not necessarily a problematic zone. However, I would argue that the intra-row zone is a much more challenging and, for me, a more exciting area to think about how we might be able to improve efficacies of weed control strategies, the weed control strategies that we use. And this is what we'll be focusing on today. Within the crop row, unfortunately, we've got this factor working against us, that the closer and closer and closer weeds grow to the crop, the more they're going to compete with the crop for available resources, both above ground and below ground. And indeed, when we look at crop yields of sugar beet, for example, as the distance between sugar beet plants and weeds increase from 2 to 8 centimeters. That distance increase can result in a yield increase of 20%. Also in a study that myself and Bo Melander did, where we were looking at cereal crops when weeds were well managed between crop rows using hoeing. So weeds are taken away between rows, but are left within the crop row to compete with the crop. A density of only 10 weeds per square meter within that intra-row zone led to yield losses of 7 to 14% in spring barley, as well as 7 to 32% in spring wheat. So we know that these weeds, because of their proximity to the crop in the row, are the most important to control. However, they're also the most difficult to control when employing our best tools that we've got in our non-chemical weed management bag, which would be direct cultivation strategies. This being because the closer and closer we get to the crop, the more and more likely we are to inflict damages upon the crop, which can also lead to yield loss. So we've got this tricky situation on our hands, all about selectively controlling weeds within this intra-row zone, while leaving the crop undamaged to prosper. As I mentioned before, today I'm going to talk about a whole bunch of different strategies, including cultural, physical, as well as preventative methods for addressing weeds growing in this area. I'm going to talk about 4 different research projects. Just to give a quick overview before we get into things, I'll talk about how we might be able to adjust row spacing and seeding rate in hoed barley in order to suppress the growth of in-row weeds. I'll talk about a study where we looked into whether we could target the placement of fertilizer, again in hoed cereals, in order to try to feed the crop while starving the weeds of nutrients. I'll talk about robot-assisted or intelligent intra-row weeding in sugar beet. And I'll talk about weed seed bank depletion strategies that might be able to be used prior to sowing to reduce weed pressure in the in-row zone, again, of sugar beet. So to get started, we're going to talk about cereals for a while. And cereals are a highly competitive crop relative to others. And they're also sown in narrow row spacings. So until recently, we did not hoe between the rows of cereals. However, due to the invention and development and availability of camera guidance and GPS guidance systems, we're now able to really accurately hoe between the rows of cereals. These machines are able to follow the crop row and therefore guide hoes very accurately between the rows of cereals, effectively managing weeds in the inter-row zone. However, one of the topics I was interested in is whether I could improve upon this hoed cereal system. I should also mention this hoed cereals is sort of coming online in the US, but it's actually quite popular, especially among organic growers in Northern Europe. So it's gained a lot of traction there. It may not be something that we've heard much about here, but more and more research and more farmers are gaining interest, if not experimenting with adoption here in the Northeast. So within this hoed cereal system, we wanted to test whether we could adjust seeding rate as well as row spacing to better suppress the growth of weeds, again, focusing on that in-row zone where we're not cultivating. We also wanted to look at whether the addition of tine harrowing after sowing, but before crop emergence could, again, decrease the number of weeds that emerge into the crop row and therefore potentially positively affect crop yield. And I have some videos in here. My internet connection may not be the best. Hopefully you at least get to see glimpses of part of these videos. So within the experiment that we did, we wanted to compare two different weed management strategies. We looked at just the inter-row hoeing alone without any additional management, and then the pre-emergence tine harrowing plus inter-row hoeing. We studied two different row spacings, 15, which would represent a narrow row spacing, and 20 centimeters, which would represent the standard row spacing in Northern Europe. And also 4 different crop densities ranging from 200 to 500 plants per square meter. Throughout this study, and as we get into results, you'll also hear me talking about effects on surrogate weeds. All that means is throughout the study, to ensure that there were weeds for us to make measurements on and draw results from, we actually planted a weed. And in this case, we planted the crop mustard in order to serve as a surrogate weed throughout the experiment. So to jump right into results, here we're going to look at effects in 2019 and 2020 as crop density increases, and what happens to in-row surrogate weed biomass, so the mustard, as well as in-row ambient weed biomass. And the first thing I want to draw everyone's attention to is just that all of these slopes are downward facing, which is exactly what I hope to see. And this just means that increasing crop density is going to be a reliable strategy for us to reduce in-row weed biomass. So it was effective in that regard. When we look at the effect on surrogate weed biomass, increasing from 200 to 500 plants per square meter, reduced surrogate weed biomass by 49 to 82%, so quite a substantial amount, and reduced ambient weed biomass from 53 to 99%. So it's variable, but effective. You'll also notice that in these graphs, in some cases, there's multiple lines showing up. The dotted lines are representing instances where pre-emergence tine harrowing was performed. So to pull out some results from that, in 2020, in one of our site years, we saw a reduction in both surrogate and ambient weed biomass, which is good. We had hoped that we would see reduced emergence in the crop row following pre-emergence tine harrowing. However, in 2019, we saw no effect on surrogate weeds and actually an increase in ambient weed biomass. This is not totally unexpected. The effectiveness of pre-emergence tine harrowing is dependent on there being weeds present. So if we have a field season where our weeds are later to emerge and aren't present at the time of pre-emergence tine harrowing, then it won't be effective. And that was the case in 2019. So responsive tine harrowing was variable. And also row spacing did not affect weed biomass. However, it did affect crop yield. So at the narrower row spacing, we saw an increase in crop yield of 7 to 8%. And this is also to be expected. This is because when we hold crop density constant and decrease row spacing, we're essentially adding more rows in the field. And this means that there's a lesser density of crop plants in any given row. It just means that the crops are going to compete less with each other, and therefore that results in improved yields. And this is a really consistent effect that we see. So we would recommend narrow row sowing. And as these hoeing technologies and the automated hoeing machines become more accurate, then we can continue to recommend moving towards these narrower row spacings. So takeaway messages for you guys. These are the important things to remember. Increasing crop density is reliable for reducing in-row weed biomass, but we didn't see increased crop yields as we would have expected. Higher yields were also achieved with narrow row sowing, so we'd recommend narrow row sowing if possible, and including pre-emergence tine harrowing, its effect was inconsistent. For the second research theme, we're going to stay in the world of cereals, and here we are looking at targeted fertilizer placement. We're interested within a overwintered cereal crop, so winter wheat, when going back into the field come spring to apply additional nutrients, whether we could make that application more available to the crop and less available to weeds by using special application methods that we'll get into. So the idea here is we want to feed the crop while starving the weeds. One way that we can do this is by, instead of spreading fertilizer over the whole field, irrespective of the in-row and between-row zones, trying to target placement closer to the crop row. Another way that we can do this is by trying to target placement depth. We know that weeds primarily germinate and establish within the very top layer of soil. And therefore, the idea being, if we could place fertilizer deeper and closer to the crop's rooting zone and further away from where the weeds are establishing, could we reduce weed biomass? I think I failed to mention as well that here we're going to be working with pig slurry. There is a huge pork industry in Denmark. A lot of people, when I said I was moving to Denmark, randomly, a lot of people were like, oh, there's more pigs than people in Denmark. And it's true, there is a massive pork industry. So pig slurry is a readily available resource for growers to use as an amendment. With regards to fertilizer placement depth, we have reason to believe that depth of placement might actually result in a differing response based on weed species root morphology. So placing fertilizer at the soil's surface might actually benefit weeds that are shallowly rooted, whereas placing fertilizer more deeply might not only help the crop, but it might actually help deeply rooted weeds or tap-rooted weeds. We also partnered with some other folks who were interested in looking at the application methods we were studying to see if they would also affect ammonia emissions, which is something of concern. It's an atmospheric pollutant. And whether we could reduce ammonia emissions by, well, one way that you can reduce ammonia emissions is by limiting its atmospheric exposure. And we can do this by reducing the slurry's exposed surface area to the atmosphere. So reducing the area in which it is exposed, as well as trying to increase infiltration rate of slurry into the soil. And again, to align this trial with our best management practices, we studied this within the HODE serial system, and again, focused on effects only in the crops in row zone. We tested this experiment in winter wheat and looked at 3 different slurry application methods. We looked at application with standard trailing hoses, which are these flexible hoses that unfortunately, due to their flexibility, aren't the best at maintaining their proximity to the crop row. You can also see that they spread the slurry in a rather wide band. And if you're able to see the video, you might also notice that there's quite a bit of splashing. In terms of reducing ammonia emissions, splashing is not a good thing. Splashing will increase ammonia emissions. So it is not the ideal practice. We also studied trailing shoes. These are a more rigid component that you can see is doing a better job at staying aligned with the crop row or just off to the side from the crop row. These shoes are also meant to interact shallowly with the soil. They're meant to create a small divot into which the slurry is deposited. However, in Denmark, especially in the West, we've got a lot of heavy clay soils. And what you'll see here is that we have a clay soil where in the springtime, we've got a really heavy crust. And these trailing shoes are not doing their job at interacting with the soil whatsoever. So unfortunately, they're riding on top of the soil and spreading the slurry in a wide band instead of focusing it within a divot. The third strategy we're interested in aims to resolve that issue by incorporating a rigid tine that runs before the same trailing shoes. And that tine is meant to break through any superficial crusting so that the trailing shoes can operate effectively and targetedly deposit slurry within that trough that is created. And you can see it's working quite well here. I mentioned we wanted to look at effects both on shallowly rooted weeds as well as deeply rooted weeds. Again, we planted a surrogate weed, in this case, ryegrass, which has shallow roots. And then we also observed the effects on a weed that was consistently present, annual bluegrass. For our deeply rooted weeds, we planted mustard, which has a taproot, and we observed effects on naturally occurring chamomile, which also has a taproot. So to get into some results, when we ask whether we could reduce the exposed surface area of the slurry, as well as ammonia emissions resulting from these different strategies, we expected that we would see reduced ESA and ammonia emissions with those tools that are meant to interact with the soil. So the tines and trailing shoes, as well as trailing shoes when compared with the trailing hoses. And indeed, we see some positive results here regarding the exposed surface area of the soil. The tines and trailing shoes method reduced slurry ESA by 61 to 66% compared to the trailing shoes alone, and by 70 to 72% compared to the trailing hoses. Now, whether that or not that related to ammonia emissions, we did see some positive results. However, we only saw this happen in 1 out of 3 site years. So in this case, we saw that the tines and trailing shoes resulted in 46% lesser ammonia emissions when compared with hoses. And also the trailing shoes resulted in 29% less emissions than the hoses. Another question we want to ask is whether the deeply rooted crop and in-row weeds would benefit from the strategies that are more targeted when compared with the standard hoses. And unfortunately here, we saw no effects whatsoever. They were too similar to each other for us to see any improved yields or biomass or nitrogen accumulation within the crop biomass. And the same went for the deeply rooted weeds that we observed. No increase in mustard or chamomile biomass or nitrogen accumulation. When we looked at shallowly rooted weeds, we would have expected that the standard hoses would have increased their growth when compared to the more targeted placement methods. But again, no methods, no results. They were too similar to one another. So takeaway messages from experiment 2, application methods tested didn't benefit crop growth, nor were they determined to be a good inter-row weed management strategy. Wah, wah. Targeted methods may, however, be beneficial in terms of reducing ammonia emissions, which is a positive to come from this trial. All right, to take a left turn, we're gonna get into the world of automated weeding and robot-assisted in-row weeding in sugar beets. Sugar beets, unlike cereals, are planted with quite a bit of space between individual crop plants within the crop row. So this opens up the possibility for in-row weeding. Specifically, the possibility for us to use some new technologies, including hoeing equipment as well as flame weeding equipment that is able to selectively operate in and out of the crop row, avoiding the crop while killing in-row weeds. The equipment that is currently available on the market, which uses cameras to differentiate the crop plants from everything else. They do so through a pretty rudimentary method. The camera essentially sees and then avoids the individual crop plants by identifying them as a large aggregate of green pixels. So in this case, there needs to be a really big difference between the large crop and very small weeds in order for these intelligent weeders to work in the crop row without reducing crop stand. So these machines are actually very effective and great to use in a transplanted crop like we see here, like in lettuce. But there's a rush now to be able to use these types of selective in-row weeding machines in direct seeded crops. And sugar beet is typically a direct seeded crop. It's also an important agricultural crop in Denmark. And as you can imagine, in a direct seeded crop, the challenge of differentiating between crop plants and weeds becomes a great deal more difficult because the crop and the weeds are each going to be emerging at the same time. They're going to be very similar in size. Also, cotyledon-sized weeds and even seedling-sized weeds are really hard even for humans to differentiate from each other at times. So this requires a great deal more of computing power. However, there are already on the market GPS-based autonomous weeding robots that are able to do this. And they do that by geolocating each individual seed as it's planted. And camera-based robots for in-row weeding are coming on board. And these are doing so by incorporating more advanced machine learning and AI capabilities. So we're getting there, but an important question that needs to be answered before these robots start hitting the fields is just how close can we get to the sugar beet plants that are direct seeded across those early growth stages where they're very sensitive to disturbance. We want to get as close as we can, of course, because those weeds growing closest are the most important to control from a yield preservation perspective. And we want to kill them as early as possible because weeds are easiest to control when they're small. So we're focused in this trial specifically on crop-related effects and damages done to the crop as hoeing distance and flame weeding distance increases. In this trial, we looked at hoeing across 3 early growth stages, ranging from cotyledon to 4 true leaves, and 6 hoeing distances ranging from 0 to 5 centimeters, all compared to an untreated control. And then we did 2 different flame weeding experiments, one where we looked at flaming intensity when flaming distance was held constant, and one where we looked at flaming distance when flaming intensity was held constant. In the flaming intensity experiment, we actually ended up looking at 4 crop growth stages from cotyledon through 6 true leaves, and 6 different intensities, which were expressed as the number of seconds that the crop was exposed to flame weeding. And those ranged from 0.1 and increased exponentially to 3.2 seconds. For the flame distance trial, we looked at just 1 crop growth stage. From talking with some industry partners, we learned that as the first true leaves are emerging, this is really when the camera-based in-row weeding systems become much more accurate at identifying the sugar beet plants. So we tested at the 2-leaf stage at 9 distances ranging from 0 to 4 centimeters. And here you can see a little video showing what this experiment looked like in reality. We had a whole bunch of pots where we grew sugar beets in. Here you can see our little hoeing machine where I hoed on all sides of the sugar beet plant at set distances. These lines on the board are helping me guide increasing distance from the sugar beet plant planted in the center of the pot. And then a quick video of our flame weeding setup. This was a fun one. We were able to use a flaming device that we could control the duration of flame, as well as adjust the distance of the pot from the direct hit of the flame. To look at some results within the hoeing experiment, what we'll look at is on the top, we're looking at, hopefully you can see my arrow, but we're looking at sugar beet biomass up top, as well as final leaf area measured as centimeters squared on the bottom. We're looking as hoeing distance increases from 0 to 5 centimeters and as crop life stage increases from cotyledon to 4 true leaves. And here we're really looking to compare everything to an untreated control. And what we can see in general that's happening is that not much is happening above 1 centimeter, 1 centimeter and above, I should say. So everything is pretty similar to the control when we hoe at 1 centimeter or further away. So that means that we can actually probably get very close to the crop, closer than I expected. Field conditions might differ from greenhouse conditions, but anyway, this gives us an idea to go off of. But what really starts happening is at the direct hit. If we pull out those direct hits, 0 centimeter hoeing distance across the 3 life stages tested, what we see is that the crop becomes more sensitive to a direct hit as it grows older. And that's just because the crop is becoming more upright and rigid. When it's younger, it's a little bit more flexible, and more plants survived at the cotyledon stage when the hoe went under the plant, but it was able to reroot and reestablish. So depending on the accuracy of these machines as they emerge, this might be some important information. Maybe we want to back off a little bit as time goes on, dependent upon the accuracy of machines as they come on the market. Notable, however, direct hits are not acceptable at the cotyledon stage either. They cause damage to the root, which results in a forking of the sugar beet. And this type of forking is represents sort of a severe quality loss because it's much harder to remove dirt from a forked sugar beet plant than it is from a normally structured one when it comes time for sugar beet processing. Next, we're going to look at flaming intensity, so increasing the number of seconds of exposure. Again, we're looking at final biomass of the sugar beet as well as final leaf area as number of seconds increase and crop growth stage increases. What we see here is that at the cotyledon stage, the crop is very, very sensitive to any flame weeding. Even 0.1 seconds of flame weeding caused quite a loss in sugar beet biomass. So I would say don't even try flame weeding at the cotyledon stage. We really start to see some differentiation in response to flaming intensity at the 2-leaf stage, where these higher intensities are, we start to see a drop off in beet size. But increasingly, the crop is becoming more and more resilient to flaming as time goes on. And this makes a whole lot of sense because the apical meristem, the growth point above ground for sugar beet, as time goes on and as more leaves develop, it's becoming essentially insulated more and more from potential damage resulting from flaming. So this makes a whole lot of sense. When we look at flame distance, again, actually quite similar to our results for hoeing distance. Anything above 1 centimeter looks very similar to the control, whereas we start to see a drop off in beet biomass at 1 centimeter and below. So takeaway messages: in-row hoeing can be implemented safely during early crop growth stages as close as 1 centimeter from the crop. However, the accuracy of up and coming technologies is going to be key, since direct hits will always cause quite a bit of damage. Also, damage resulting from direct hits are going to become more severe at later growth stages. In addition, in-row flaming should be performed at distances of 1 centimeter or greater than 1 centimeter, and should not be implemented at all during cotyledon stage. The crop becomes less susceptible to damage from flaming as it grows. All right, our fourth and final research theme, I might go a minute over, but bear with me, is looking at whether we can reduce the weed seed bank prior to sowing of sugar beet. So reducing the weed seed bank targetedly within the crop row. And this is all based on a 2-year system, where in the first year, we're growing a crop. In this case, we grew canola, and we cultivate in what is the inter-row zone of that crop repeatedly to try and reduce the number of viable weed seeds in that area. And if this sounds unfamiliar, I'm going to explain exactly what's happening in year 1 in our next slide. But having attempted to reduce the number of viable seeds in the inter-row zone in year 1, then with GPS technology, purposefully come back and in year 2, plant sugar beet into what once was the between row zone, now becomes the in-row zone, where hopefully we've depleted the number of viable weed seeds and therefore have fewer weeds emerging into the crop row. Something very important with a strategy like this would be that we have no deep cultivation or soil inversion between year 1 and year 2, because that would essentially erase the effect of what we've tried to do in year 1, decreasing the seed bank by churning the soil and bringing new weed seeds up. So I told you, I promised I'd describe what was happening here in year 1 as we tried to quote unquote reduce the weed seed bank. The weed seed bank just refers to the number of living weed seeds in the soil. Before I mentioned that weed seeds typically only germinate and establish in the very top few centimeters of the soil. So as we know, when spring comes, those weed seeds in the top few centimeters of the soil are going to get plenty of environmental cues to germinate and establish. We see that happening in our fields right now. But when they're small, we can easily go through and we can kill those weeds, thus removing them from the weed seed bank. Unfortunately, cultivation also gives a number of great cues to persisting weed seeds in that upper few centimeters of soil to also germinate and establish. These cues include a well-oxygenated soil. It includes exposing those seeds to a flash of high-quality light. And it includes a potential flush of nitrogen resulting from cultivation. But remember, I said we were interested in repeated cultivation. We can continue theoretically to cultivate in order to continue removing weeds from that upper layer, thus depleting the weed seed bank. Hopefully that makes sense to everybody. So it's in this study we wanted to look at both cultivation tool and frequency of cultivation in that first year in the interrow zone to identify what was most optimal. We looked at 2 different cultivation tools, a more aggressive option, a PTO powered rotavator, as well as standard hose, and 5 different cultivation frequencies ranging from 0 events to 4 events. To measure our effects, we went out and took soil samples down to a depth of 5 centimeters before treatment and also after treatment. Then we took those soil samples into the greenhouse and germinated all of the germinable weed seeds in the soil and counted them, then compared the number of weeds in the soil after treatment to the number of weeds in the soil before treatment to see if we had depleted the weed seed bank as we'd hoped. And unfortunately for me, the results of this study are pretty easy for me to convey to you. If we look at the change in weed emergence, so change in the weed seed bank in both of our site years, as cultivation events increase and across our 2 different cultivation tools, the shares in the blue and the rotavator in the red, we see that there's quite a lot of variation represented by these bars surrounding each point. And not a whole lot of difference between either the tools or the increasing number of cultivation events. So we saw no effect. We also went out and just counted the number of weeds that had established in the crop row. And again, saw no significant effects to speak of. However, we will delve into whether there might be species-specific effects. The emergence periodicity, or when weeds emerge throughout the growing season, differs among species. So it could be possible that this is an effective strategy for some weeds, but ineffective for others, depending on whether or not they're present during the time of cultivation. our takeaway message is that this did not work well. However, we will see if it worked well for specific weeds. And with that, thank you so much for your attention, to all those who have contributed to these projects. And also my contact information is here if anyone's interested.
Great. Thank you, Margaret. That was excellent. Beautiful slides.
Oh, thanks. A lot of information, I know, but thanks for coming along for the ride.
We have a question in the chat from Thomas Bjorkman. I think this was in regards to your first project that you presented. You were speaking about the effectiveness of tine harrowing being dependent on whether the weeds are actually present at that time. And in the trials where they weren't, when the tine harrowing wasn't effective, when it didn't add anything to the sequence, did you know at the time of harrowing that there weren't weeds present and that it wasn't going to be effective, or not?
Our surrogate weeds had germinated, so we would have expected that there would have been a reduction of the surrogate weeds, but there was not. We didn't observe it in the intra-row zone. We are also, when we're studying effects in the in-row zone, we're also limiting the area that we're observing within, given that we're hoeing between crop rows. So that can be a contributing factor, but still, we would have expected to see an effect on our surrogate weeds. With the ambient weeds, let's see, weed density we did measure beforehand, and it is something that I can go back and look at. I think we might actually even delve into this in the paper, but I can't off the top of my head quote as to whether there were more or fewer weeds present between those 2 years, but it is something that we measured. It's a great question.
Any other questions? If not, I've got a couple.
Yeah.
So on that last project with the seed banks, did you prevent all seed production in those fields, or were there weeds, for example, in the in-row zone going to seed that that the seed may have spilled over into the zone where you were trying to manage the seeds?
We observed whether or not there was enough weeds established within the in-row zone, or large enough weeds wherein weed seed rain could potentially have affected or skewed, I would say not skewed, but nullified effects in the crop row. We didn't see it. However, it's not out of the realm of possibility. Yeah.
Okay, any other questions? So I have one other one. On the sugar beet research, where you found that actually the young beets were able to survive the in-row cultivation, the direct hits, better than the older beets. That's kind of shocking, isn't it? We're always talking about how cultivation is more effective on the smaller weeds. Was that a shock to you? Are there other weeds with similar morphologies as beets that maybe would survive at the cotyledon stage, or when they're very young, better than when they're older?
Yeah, a few thoughts come to mind. So this was a greenhouse trial, which means that the environment that we studied sugar beet effects under are far more controlled than they would be in the field. Our hypothesis was that the younger beets would be more sensitive to cultivation, and they would become less and less sensitive as time went on. But like you said, it's surprising that we see the exact opposite. But when we think about it a little bit more, or when we had to reconcile the results that we saw, it actually makes quite a bit of sense. We're using a tool in that experiment, what would be called a side knife, that's operating below the soil surface. And in the experiments that we did, as you could hopefully see, it actually wasn't causing that much soil disturbance. So the primary mechanism under which that cultivation action was happening would be to undercut the plant. So because the sugar beet was small, it was able to survive undercutting. In the field, just from having observed these tools operate, there's not only undercutting happening, but also burial. So this is something in that trial, you can only talk about so much, but in that trial, we also would highly recommend taking these results and also replicating them in experiments outdoors. And that might actually be something that Bo is going to pursue in future years. I would expect that, well, cotyledon-sized weeds, for example, may be able to survive, or cotyledon-sized sugar beets may be able to survive undercutting, that they wouldn't be able to survive much burial. So it may, our results may differ as this is explored in a field setting.
Great, yeah, that makes sense. All right, so folks with a special interest in the topic that want to meet with Margaret with fewer attendees on, are welcome to stay. If not, let's thank Margaret for an excellent presentation. And yeah, if you've got to go, that's fine. But yeah, if there's anyone that with a special interest that has any particular questions, especially any farmers that are on the call, I'd love to hear your thoughts and questions on this topic for Margaret.
Thank you again for coming.
Well, that's good. A farmer question.
Please.
So we just had a camera guided cultivator delivered.
Oh my goodness. Okay.
And we have a 1/4 acre of red beets planted that we're going to have the company rep come and help us set it up so that it works properly. The beets are not up yet. So we don't know when they're going to be the right size, but it sounds like we should wait for them to get a couple of leaves on them at least before we have the tech come up here.
Yes. Again, proceed with caution with the results. I would say that the results from that cultivation study with the beets specifically, right, which sounds like they could be directly transferable to your case here, may be more interesting to fellow researchers than they are to farmers at this point. Just because, again, we haven't studied in a field setting.
Right.
And so I'm guessing that you're using a tool that's going to be able to follow the crop row, and you'll be doing between row hoeing. Okay. Yeah. We've got basically the same knife for between the row that you had, and then we've got the rubber fingers in the row. Yeah. And do your knives, so if the sugar beet plant is growing here, do your knives angle away from, or do you have them so they're angled away from? Yeah, Brian knows the answer to that. Good. That also might protect you quite well from burial, because the only soil movement, and Brian, correct me if you've experienced differently, because I think you have a little more experience with this, would be coming off of that front edge of the knife. And I wouldn't expect there to be very much. So important questions to ask the technician who comes and helps you calibrate would be about the accuracy of the hoe that
Mhm.
you're going, the guidance system,
Yeah.
whether you're able to get within 2 centimeters and feel
Right.
good about it might
Right.
depend on whether or not there's a plus or minus on either side of that 2 centimeters
Right.
of an additional 2 centimeters.
Yeah.
Or if it's 1 centimeter,
Right.
then maybe go for a 2 centimeter distance as
Yeah.
a target.
I think one of the questions that he was concerned about is whether the camera would see the crop row
Yeah.
accurately enough. So we shouldn't have big shaggy plants, I guess, either. I'll get to
Yeah.
them for that. But there was a question of whether the space between the front tires was wide enough that the camera would see 3 rows up ahead or something like that.
Yeah.
It's a 2-row cultivator, but they want a fair bit of information for the processor.
Right. And other sort of cultural methods that might be worth your consideration or even like experimenting with might even include experimenting as to whether or not you can plant at a higher density
Mhm.
in order to get more rapid canopy closure.
Yeah.
Beets are slow to grow.
Yeah.
And my experience with the row following cultivators is all in cereals, where as soon as they're up, they're already dense
Right.
enough that
Yeah.
you can follow the row.
Yeah.
So yeah, I think you're on the right path with working directly with the technician.
Yeah, they want to make sure that it gets set up properly.
Yeah.
So basically it's a GPS guided tractor and it's just a little side shift in the cultivator itself.
Cool.
And that raises the question with the Danish, well, I guess they're sugar beet growers. We'll call them vegetable growers. Be nice about that. But do you assume that they are all using GPS guided tractors when they're going to cultivate?
Yeah, they are.
It looked like all of your tools really depended on extreme accuracy.
Yeah, the top 2 barriers to the level of adoption of technology that I saw there versus here would first be access. There's differences in the agricultural system that makes it as such, so it's easier for growers to quickly adopt those technologies, and we can get into that if you're interested. But the second would be rocks. The first question I always get in New England is like, what's going to happen to that beautiful, I know Brian's heard it too, what's going to happen to that elegantly designed tool when I hit a boulder? Yeah.
We had a cultivator salesman drive up with his fancy cultivator here, look at the soil and turn around and for other provinces.
Yeah.
It was not going to survive. So that yes, is an issue. And the crust. So yes, for our finger weeder or the rubber fingers, the tool has a little tiny cultivator thingy right in front of that so that it digs into the ground because it's not going to break the crust on its own.
Oh, wow. Yeah. Yeah. So are you considering also, or can you, with that cultivator also, we didn't even touch on it today, but in row cultivation tools like finger weeders and brush weeders and torsion weeders are options as well. Would you try adding those as well?
Whatever works. That's for our weed science people to work out what's going to work for what situation because it's so specific. Like you were talking about in the beginnings, have the weeds germinated yet or not? It makes a difference what you use. How big are they? Do you have a dry crust on a moist soil, or do you have moist all the way through, or is it all rock hard? And that changes from one day to the next. So
Yeah.
Our growers need answers to all of that with the understanding that we get crusts and rocks and large clods that are limitations that they don't have in Salinas or on the Muck or other places where these tools are being developed.
Absolutely.
Yeah. But I'm glad you were able to bring the Danish experience to us, because there's a lot happening there that you need to be on top of.
Yeah. Yeah. It was an exciting place to be as a non-chemical weed management enthusiast. Lots of toys.
Yeah.
Are they getting into electric and laser weed control yet there? Or?
I went to, I also have to preface, my experience was unfortunately jolted a bit by the pandemic. I ended up for over half of my time there being confined to my attic. So I didn't get out as much as I had hoped. But I did get to go to one trade show where I saw one electric weeder. So that was present. And also the, do they call it the comb clipper, designed to take off tall growing weed seed heads before they've set seed in a shorter crop by cutting. I also saw in the barns of some large organic growers as well.
Yeah, the comb cut actually goes at the base of the crop.
Oh,
Yeah, it has these knives on it, so your crop is theoretically more flexible than some of these straight stalked thistles and other weeds that they were dealing with. So the crop kind of bends and doesn't get hit by the knives, but the more rigid stems get sliced. So it goes right through the crop.
wow. Okay. Yeah. Never seen it in action. So that's very interesting.
I got sort of an opposite pandemic benefit that I ended up giving a talk sort of across the water from Aarhus in Skåne. I gave 2 talks to growers there.
No way.
At virtual conferences.
Wow. So what is your experience and thoughts on differences in challenges that you face versus your impression of the challenges they face?
Well, remarkably similar. I mean, it really comes through. I have a guy that worked with me almost 20 years ago now, who's been doing vegetable research and extension with growers in Togo in West Africa. And they're not quite as automated, but in terms of what are the mental barriers, social barriers to adopting new things, they're exactly the same. There's absolutely no difference. So people or vegetable growers around the world seem to have a lot in common.
Yeah.
The Swedes have more restrictions than New York State on chemicals. So that's definitely a piece of it. And also with nitrogen management, one of the challenges that they're running into, and the soil scientists in Sweden have been doing maybe even more work than the Danes on this, is that the requirements of organic production there prevent them from producing enough nitrogen to maintain enough organic matter inputs. That basically, if you're growing your own nitrogen and supplementing with, it would be hog manure in Aarhus, but you need to produce a lot of biomass, and you need a lot of nitrogen to produce that much biomass to really be sustainably organic, and they just have trouble hitting those production levels. And we're just warm enough and a little bit longer enough that I think we can do it. Not that we're doing it regularly, but I think we can have rotations that meet those requirements.
Yeah. Yeah. In addition, regarding adoption, I grew up in Maine, and as Brian said before, I've been involved in research at universities and trying to do outreach with that research for 6 years, 7 years now. So I'm familiar with our system, but it was interesting just how different it was in Denmark. Scientists and researchers had nearly zero interaction with farmers.
Right.
And in fact, there was a whole system of agricultural advisors that was very, very much adhered to by growers, where they would go to these advisory services where they would sort of serve as a middle ground between incoming research and the grower, and feed them recommendations. So a lot of adoption sort of has to go through that barrier, so to speak, but also in some cases it helped with that adoption. But it also leads to a weird situation of a lot of the growers are doing the exact same thing. So in terms of biodiversity at the scale of country, there's not as much.
Right.
So I only saw one organic vegetable farm, and the rest were growing these prescribed, I shouldn't say prescribed, but these variations on a narrow number of crops and how they were cultivated. It was interesting.
Between markets and subsidies, it seemed very controlled. So
Totally.
the Swedes had decided that there were a lot of crops that if they're going to be part of the EU, they just can't grow those crops.
Wow.
Because they can't compete with Hungary or Portugal or wherever. So they're just out of them. So they grow cabbage and they grow carrots and they grow some onions. But that's kind of it for vegetables. I mean, they have some for local, but in terms of wholesale production, they just can't. They can't make the money doing it. So things that handle the long days of summer, and cabbage is certainly one, that works. They have a competitive advantage. But they're also, it was the same structure. HIR was basically the farmers' co-op is what it started off being. I forget when it was founded. I think it was in the 18th century. It's been around for a while. Longer than the university research, that's for sure. So I was invited to speak, and the researcher from the Swedish university was invited to speak. So we unsurprisingly had basically the same message.
Yeah, with organic farming, weeds are a problem, and how do we get rid of them? It's a through and through.
Oh, that's sorry you were cooped up for that long, but that's been a university that's really done a lot of nice work, and having both the sandy soils and the clay soils, you really get a range just because the cover crops at least behave so differently on the two soils, and they have different functions. Cover the range.
I just want to ask, there's two other folks online if you have any questions or comments. Maybe they just don't know how to turn off the
we lost one.
Lost one.
If you see in the bottom left, there's a mute button. You could use that if you like. But well, thanks so much, Margaret. And those were some of the most beautiful slides I've ever seen.
Oh,
a lot of time on making those with those icons and pictures and everything. They were fantastic.
Good. I hope they helped. It is.
What's next for you? I professionally, what's next for you? I have.
We will see. I am handing in. I'll defend in October, so I have some time before then to figure out what's happening. But I would like to stay in New England, so I'm seeking opportunities within this area. Potentially continue on the research train. There's an opportunity to continue at UMaine, which I might take up, just finishing off some already completed projects. So we will see, but not determined yet.
New York isn't so far from New England.
That's true, just barely not. I always want to say that it's part of.
You can still be on Lake Champlain and be in New York.
Yeah. Yep, yep, yep.
So
Right.
we've got one Vermonter who moved across the lake.
Yeah.
Hmm.
Yeah, I need to come make a visit and see Brian and what he's up to as well. So
Great.
we'll come check it out.
All right, great. Well,
Cool.
thanks for the talk.
Yeah, thanks for your
Right.
participation and sharing your experience as well. I learned a couple things and appreciate it.
Great. Well, we learned a bunch as well. So thank
Yes,
you.
absolutely.
Yeah,
Bye-bye.
cheers, guys. Thank you.
Bye-bye.